I want to show a fundamental advantage of sets over lists and tuples, and that is that you can search in a set much faster, at least when the set is large. So I'm going to make a list of length uh, on the order of 10 million or 1 million. And so we could write 10 million by just typing out all the zeros, but that's definitely not a good way to do it. You could try doing 10 to the seventh, but this power symbol here, this caret symbol, that does not mean exponentiation in Python. It means something else. I think it means bitwise addition, but if you don't know what I mean by that, just forget it. The important thing is to know that you cannot do powers using this symbol. Instead, you use star star. Okay, so now that we know how to make this 10 million, let's make a range object using that. Let me say r equals range, go from 0 up to 10 million, and let's go up by 3. Okay, so let's convert this to a list. So let's say my list equals list r, and let's convert it to a tuple. We'll say my tuple equals tuple r. If you wanted, you also could have done tuple of my list. They replaced this r with my list. That all sort of worked fine. And could do same thing for my set. So turn this range object into a set. And okay, good. And now let's check, is 0 in these things? So the way you do that is with the operator in. So here I write 0 in my list, and that returns true. If I write 1 in my list, that will return false. And it works the same with my tuple and same with my set. And if I want to time an operation, this, as far as I know, is not a Python thing. This is a Jupyter notebook thing. And I can put time it at the beginning of the cell, and then whatever comes after that in the cell is going to get timed. And it'll be repeated probably a few times. It'll be repeated a lot of times if it's fast. And then Python will report to me how long did it take. So let's time how long it takes to check if 0 is in my list. Okay, so I mean, I never really look at this part. This is saying how often it repeated through each run. Then each run corresponds to repeating this like 10 million times or so. And then it takes what is the average among these, something like that. But I usually ignore all of this stuff, and I mostly just look at this portion. And so this is saying 36.2 nanoseconds. So this is saying 36.2 times 10 to the negative 9. Okay, great. Let's try the same thing for my tuple. And it'll probably be a little different, but I think it's going to be approximately the same. Yeah, so approximately the same, 38.4 nanoseconds on average. And okay, I told you that it's going to be much faster for sets. Let's see. So I'm timing how long does it take to check if 0 is in my set. So it seems like I was wrong with this because here it's like slightly more, 42.9 nanoseconds. So what's the reasoning for this? Well, let me show you what happens if instead of checking for 0, we have to check for 1. And why is this going to be different? It's because to check for 0, I mean, we can just see that the first element is 0 and then stop. Whereas to check for 1, I mean, Python certainly doesn't know this is an increasing list. So it has to go through all of these million plus elements to check. So it looks pretty similar, but notice this is milliseconds rather than nanoseconds. So this is like a million times slower how long this takes. Whereas if we try this for sets, this is going to be much faster. And you can see here it only did 10 loops. So here it's still nanoseconds. It's essentially the same. Took essentially the same amount of time to check for 0 as to check for 1 in the set, whereas it took a huge amount of more time to check that this 1 was in my list, as opposed to checking that 0 is in my list. And same thing sort of happens if you're working with dictionaries. If you want to check if a certain key is in a dictionary, you can check that very fast. And it's for the same sort of reason. And it's related to the fact that, for example, you can have tuples as keys in a dictionary. You can have tuples in sets, but you cannot have lists in a dictionary, and you cannot have lists as the key. Um, Sorry, you can't have lists in a set, and you can't have lists as a key in the dictionary. So that's just a quick example of one of the big advantages of sets over lists and tuples is you can check true or false is an element in the set. You can check that much faster for sets than you can for lists and tuples, at least as long as the set is big enough and there isn't some like special reason it's wrong. Like, for example, here we were able to check for 0 quickly, but in general, checking for an arbitrary element is going to be much faster in the set version of R than it is in the list or the tuple version of R.